you. So thank you. Pleasure to be here. My name is Stefan Lindgren. I'm the CTO of Talkpool. Talkpool has been around in the LoRa space since the very beginning, where we are both producing devices and we are doing networks mainly in the Nordics and in the Middle East. So, security. You might think that, hey, I'm only doing a temperature sensor. Security, how difficult can it be and how important is it? So I took some measurements from my colleague that were away during the Christmas holiday here. And yeah, maybe hard to say, but in the upper you can see the temperature outdoor and 2 measurements indoors. You might be able to say, okay, it was more flatter, he was probably not home, but maybe not that obvious. And in the lower part, it is the relative humidity that is also part of the sensor. And also there you can see, okay, it's flattening out, but you can't really tell that much from it. But if you're looking for the absolute humidity, for example, then you can just with one measurement see if somebody is home or not, because then the absolute humidity in the building are getting the same outdoor and indoor. This is, by the way, a lot what we are doing when we are doing measurements with the construction company, finding problems with molding and problems with heat and moisture in roof constructions. So yes, even if you do just a simple, stupid temperature sensor, IoT security is key. It is kind of a necessity that we are doing this right. And there's a big risk that we are destroying kind of the IoT possibilities if we are not dealing with security in a proper way. And LoRa as a technology is really good on security as well. And it's really an edge that we should push as soon as possible, because we have the possibility with the overlay secure network. For example, if you go into the industries, that you're not part with insecure elements within the domains of the industries, but you can do that securely on top of it and having controlled way. So I think security we should really take care of. This is a real strength in LoRa, and I would try to explain a little bit what we have done and why and the benefits of it. And please, if they have any questions, just shoot it. So when we started up with the first devices back in 2016, we came from the telecom sector and doing smartphones and similar, and knew kind of what was the paradigm in smartphones with the trust zones and key storage, SIM cards, and all of that. So from the very beginning, we started building in secure elements in our solutions. And we are using a hardware-based solution, crypto memories, using an Atmel ECC 608, which is a separate unit. It is the one in orange in the picture. And it's really designed for with the separate processing, separate EEPROM for storage of keys, and it is super secure. You can't probe it down, you can't drill it down, and it's a huge of effort even to just crack one single device. And one of the benefits with this is also that you can having a pre-provisioned with transport keys. So when you are ordering it from, for example, Microchip or from the other competitors there, you can get it with the transport key. So you're having a secure anchor already from the beginning. And you don't need to have any key handling at all in Visible. So what we are using is that we are deriving the keys in the secure element itself. We are just storing in the factory an assault or a nonce that is giving us enough information to know what the key is. And we also not letting the EMS, even if we are using a trusted manufacturing partner in Sweden, which we really like and appreciate, they never see our firmware in clear text. They are only handling encrypted blobs that they are pushing into the device, and they are getting out like a salt that is only giving kind of an ID, so we can generate the keys back in our backends as well. And when you're doing devices and when you want to have it secure, then it's a number of steps that you should go through and check. And one of the first thing is looking at the booting process of the MCU to harden the initial boot. That is when deciding which firmware to load and getting the basis up and running. And there you can also lock the device. If it's not the right software, then it's a brick. The second step is to secure the link between the secure element in orange and the processor in red. So it's really important that you are not able to probe the communication as well. So you're setting up a secure link based on the pre-shared secret that you know and that it's coming from the crypto memory manufacturer. And when you're doing that, then you can making sure that it is the right firmware that is downloaded. It is your device, and you can close it down if not everything is correct. The next thing to do, that is to de-encrypt the firmware. And it's also part of be able to do secure firmware over the air or firmware upgrade in general. Both to see that it is a legit firmware version, to see that it's not broken in the transmit, and doing that it is from a legit source. So if anybody is changing any bits in the information, the integrity is false, and the device doesn't boot. So it is really secure there. Using a crypto memory also means that you don't need to handle any of the keys in the MCU itself. All security mechanisms are done in the crypto memory. And by that, it's never exposed, not even in runtime, the keys are exposed in the MCU. So that makes it really hard to crack even a simple sensor. And it's not also possible to do backwards engineering to decompose the files in order to find attack vectors for the code itself. Then on all the MCUs and so on, there is a lot of debug interfaces, programming interfaces, and so on. So during after the initial boot, it's also very important that all of those are closed down. So even if you may be only able to break one device, but that gives the attacker a possibility to start finding attack vectors in order to compromise the network. And even if they're not able to come to the information, it could just be that they are threatening to, for example, brick all your devices that you have out in field. So today in security, a lot of the threats are more towards ransomware or threats that they will destroy your assets rather than also just stealing the information or injecting information. And when you're doing that, then you can put the full MCU in to read protected. So as soon as somebody is trying to read or trying to get into the MCU, all the runtime memory and everything is just wiped, so that there is no risk that anybody is doing it. So these are kind of the basic steps to making a state-of-the-art hardware when it comes to security, and following kind of the basis that is common in the cell phone parts, using trusted elements. But here we're using this hardware secure element instead. Okay, so now you have secured your device, but hopefully all of us are hoping that we are able to get huge sales, and the potential are huge of shipping hardware. Then it's really important as well to getting a smooth distribution chain in order to having a mass deployment. And the secure element can also help in that case, together with, for example, what we have done together with the things industry. So the targets that we are after, it is that we could have one single SKU that can go to all the different customers. So just having a shelf product. And also that we can support different distribution chains in several steps, and having a unique or unified way to handle the keys. So we don't need to send a lot of encrypted firmware with the keys, or not knowing who has access to the keys, but rather just get it working. And another thing is also having the delayed customer binding. So preferably when we're shipping out the devices, we don't really need to know or want to know exactly who the end client is. It can be a small business that maybe just have bought 5 sensors, or it can be a huge corporation that is handling thousands of sensors. It has to be kind of a unique or unified way to handle it in order to support the mass deployment. And preferably also to having the full flow digitalized. So we don't need to have the manual interactions between it, but have it from the purchase order down to the factory and then to the end client. Having that full flow digitalized, so we don't need to rely on the sales guys to really send the key, and that the distributor should send the key to the end clients. So this is our goals in the design of the solution that we did with the TTI. And what we came up with is the simplified and secure device provisioning. So what we are doing is in our factory, and in any kind of factory, we're of course producing the units. We have the secure element in our products. And from that, we are in the production creating a manifest with the salt, with the nouns for each one, in order to understand which device has been produced and which one should be able to be claimed. These are sent in encrypted format and automatic into the joint server by the Things network. So even if these manifests are getting into the wrong hands, it is encrypted, so it only can be de-encrypted in the joint server. While the distribution chain are kind of similar, it's just shipping of hardware. So we can have a shelf product, we can send it to the distributor as shelf product, and the distributor can send it out to whoever. They don't need to keep track of, okay, which batch was it, where can I find the key, and so on. It's all just sending the hardware distribution. When the installer comes at site, we have QR codes on all the devices. He can scan the QR devices and then claim it towards the join server. So when you're doing the join, the keys and the information are already in the join server, and it works through any of the networks that is connected to the Things Network's join server, and also on the open source version of the join servers here. So by that, we are both enabling massive deployment, really easy distribution chains and so on, and also make it easier for the end clients, with the benefit that it is total secure, that there is no open text keys seen anywhere, and you can really rely that your security hasn't been compromised. And taking that together with also the security handling of the firmware and securing the device in general, that is a very good package. And it's all dependent on this secure element that is kind of the ultimate anchor when it comes to the security in the solution there. So the TTN join server is supported by all the Talkpool products. And it is kind of, as you saw this morning, a lot of other vendors is also starting to support it. For our sake, we are mainly having devices when it comes to smart buildings, when it comes to energy optimization, or for some meterings of water, or different customer solutions. So, in general, I hope that I gave you some inspiration and some thoughts of when you're designing products, what to think of, and how to really raise the bar, and making sure that the LoRa devices that is out on the field are super secure, and that we are able to push it to mass market very soon in an efficient way. I don't know how quick I was, but is there any questions on the different topics?
Always a bit exciting to ask questions in the audience.
Yes.
All the way there. If you hold on, then I'll run up to you so everybody can hear you. It was here, no? Oh, sorry, one further.
Hi. How much does it add to the BOM costs to make it secure?
It's about 50 cents. So in volume, it's not a huge cost, and you are easily saving that in the distribution cost for it. Then, of course, it is some initial investment in getting the whole architecture in place and so on, but it's not a significant cost in the BOM.
Aha, you make me go from one place to another. Sorry, sir. Very good.
Hello. How do you change the owner of the sensor if it happens?
Sorry?
How do you change the owner of the sensor? If the sensor gets from one hand to another hand, a new proprietor, a new owner.
Okay, yeah. So this the solution today, it is to handle the initial join and the distribution chain from the factory through different distributors down to the end clients. We are looking also to having additional functions of handing over sensors from one client to another. We think that we can use it a similar methodology, but that is not described in this presentation. I think as we are sending out more and more sensors, and more sensors are also built into buildings or more built it, I think it's a very relevant question, and absolutely something we are looking into to see how we can securely both share the secrets, doing and protecting the data, so only the legit owner of the sensor can decrypt the data. But the solution here described is not handling that part.
Okay, there's one last question here. Yeah.
Hi. How are you handling the manifest file upload from the factory floor to the joint server securely? Yeah.
So from the factory, we are getting the salt for the different parts. That goes into our production server. And from the production server, we are automatically creating one file per batch that we are producing. And that one we are signing with the keys for the things network join server, or any kind of join server that would like to have those specific keys. And then we are sending it over in a secure way to the join server. And then the keys can be derived in the join server. So it's getting all automated from production to us, but it goes through our production servers in our R&D.
Is that an answer to your question? Yeah? Okay. Thank you so much, Stefan Lindgren.
Okay, thank you all.